So the most important topic in irrigation, let me say instead of important, most confusing topic. Students are worrying a lot how to face this kind of topic in irrigation. When to multiply, when to divide it by. Efficiency, sometimes we do multiplication. Efficiency, sometimes we do division. So that confusion today, I think that will be get rid today. So irrigation efficiency. Before going to talk about the efficiency, what is the necessity of efficiency? For what purpose the efficiency is required to be considered? Viral garu aa gaya. Viral Chaudhary, for you workbook is not available here. Is it okay for you? Good afternoon, Nikita. So the irrigation journey of a source started from a reservoir. This is the source or reservoir. The journey of water initiated over here. Journey of water started over here. So this is water. Your agricultural land is located somewhat some other location. This is agricultural land. Agricultural land. During the journey, from this reservoir, water is coming out, traveling, and bring down the water towards a field canal. This is a field canal. Field canal. So will 100% of water from reservoir reach the field canal? Whatever water travelled from reservoir, will it reach the field canal? Please tell me, guys. During the journey, there are evaporation losses. During the journey, there are evaporation losses. There is a seepage into ground level. Seepage into soil. There is a seepage into soil. Yes, theft by Anshu garu, human loss, human utilization. So, the water course which has been started initially, for example, 100 liter. Field canal receive only 75 liter. For example, I am saying numbers just for your understanding. For example, I am saying. Now, this is given to some method of irrigation. It may be a sprinkler irrigation method. This is taken and given for application through sprinkler irrigation. This is field channel, FC. Field channel. Field channel is giving water through sprinkler irrigation. Field channel is giving water through sprinkler irrigation. Water is falling down. Water is falling down. So during application there are losses. Application losses. So that sprinkler irrigation sprinkling onto the land. Okay. Sprinkler irrigation sprinkling water onto the land. Sprinkling water onto the land. So for example, we have taken here, this is the land, water is sprinkled over here. This is the land, water is sprinkled over here, land. So again application loss, 75 liters of water over here, received only 65 liter onto ground. there will be escape of water through evaporation, there may be wastage of water during application. 65 liter reaches to surface. 65 liter reaches to surface. Then this is root zone. Root zone. Water on the ground level can undergo surface runoff. Water on the ground level may undergo surface runoff. And some water will go very deep. It will go to groundwater table, deep percolation, and finally at root, maybe 50 liters of water available. So how many started from the journey? 100 liters started from the starting source. At the root zone, finally 50 liters available for plant. Among 50 liters, plant may take 40 liters or 35 liters only. Understand that? The journey when it is started 100 liters at source, at root zone finally 50 liters available, and in the available 50 liter, plant is going to take maybe 35 liter or 40 liters only. So around 50 to 60% of wastage losses. So that you need to estimate the efficiency. You need to estimate the efficiency. That efficiency we can say the ratio of water output to the water input. Ratio of water output to the water input expressed in percentage. Expressed in percentage is called as irrigation efficiency. Ratio of water output ratio of water output to the input, ratio of water output to the input in terms of percentage, that is called as irrigation efficiency. That is called as irrigation efficiency. Generally what we call losses, you are giving total input of 100 liters minus remaining output of 50 liter. That is called losses. That is called losses. Input minus output. That is said to be losses. Input minus output is losses. Losses are increasing. What happened to efficiency, Ninath? Losses are increasing. Yes, Adarsh Anand Garu, BPSC also it is helpful. BPSC solid waste management course also it is included, Adarsh Anand. Yes, efficiency decreases, losses increases, efficiency decreases. So losses is input minus output. Loss increase हो गया, efficiency decrease हो जाएगा. So efficiency inversely proportional to loss. Efficiency inversely proportional to losses. So we are considering over here, output by input into 100 irrigation efficiency. I am not talking individual efficiencies. I am talking overall efficiency. Overall efficiency, output upon input into 100. Output upon input into 100. So this will be easy output. Output we can measure with respect to how many area of land irrigated. How much area of land irrigated into how much area of land irrigated into depth of water. Depth of water available for use. Please understand, use actually available for utilization. Depth of water actually available for utilization. Depth of water used upon source will give some flow rate. Flow rate from source into time of flow. Flow rate from source into time of flow. Flow rate from source into time of flow. That is output. That is input. Output by input. I would like to make it simplify for you. Irrigation efficiency A into dW upon Q into T into 100. It is very, very easy formula. Just you are taking volume in two different terms. You are taking volume in two different terms. Irrigation efficiency is equal to area of land irrigated into depth of water used upon flow rate into time. Output is nothing but finally how much depth is available at the land. Viral Chaudhary. Finally, how much depth is available at the land? Water depth available at the land. How many areas of water, how many hectares of area irrigated by the water? That multiplication. So in simple we can take A into dW upon Q into T, whatever type of irrigation. Whatever the question, whatever type of irrigation, efficiency is equal to A into dW upon Q into T into 100. Now you have confusion when to multiply, when to divide. Sometimes we are multiplying efficiency, sometimes we are dividing efficiency. Sometimes we are multiplying efficiency, sometimes we are divided by with the efficiency. Please carefully listen this. If you need a design value is required. Always design value is greater than actual value. Always design value is greater than actual value. What is the design value? Q into T. Then actual value A into D by efficiency. Design value is Q into T is equal to A into D by efficiency. It is easy for you then. It is easy for you then. Understand this. Actual value. If you need actual value A into dW, Q into T into efficiency. Q into T into efficiency. Now your all confusions will go on. Please understand. So when you want to find out design value divided by efficiency, area into depth by efficiency. Yes, design हमेशा discharge का respect में हो जाएगा, no doubt. Design is always with respect to discharge. Actual value of flow, actual value of depth, actual value of discharge, whatever it may be. Design capacity, actual capacity. Capacity you take Viral Garu. Viralji, capacity you take actual capacity, design capacity. So when you are taking design value will be taken at a head or at a source. At a source. Actual value will be taken at a tail. At agricultural land. At a root zone. Whatever values you consider. At a root zone, at land or at a tail. That is actual value. Tail, land or root zone, actual value. Head or source, design value. Q into T is equal to A into D by efficiency, eta. Got it? And you remember this, always design value greater than actual value. Always design value greater than actual value. Yes, that is factor of safety. Correct. Correct, Viral. That is a factor of safety. Efficiency is nothing but factor of safety for design. Means, for example, you designed for 120 liters. Actual requirement may be 60 liters only. Remaining 60 liters is loss, wastage. Loss or wastage. So that delivered is 60 liters at the ground. Out of 120 liters, during traveling, during application, during passage into ground level, during storage at root, during passing into seepage, some amount of water getting wasted, 60 liter. Remaining 60 liter available at root zone for the plant growth. Effectively available water at the plant. Understand? Understand? Is this clear to everyone? Tricky questions you will get tomorrow in special class we will do. Today we'll finish the theory and a few questions. Tomorrow in special class only efficiency related questions. 1 hour session tricky questions we will do. Water conveyance efficiency. There are different types now. So actually as per our exam required is that one over. Okay. As per requirement of our exam, the previous one that is over. Test is tomorrow. Correct. Sudhakar. Today we'll finish the theory and small question, and you revise it by today full. Tomorrow you have test. Okay. Riya garu, are you going to decide the timing? Every time एक दिन you are going to say 2 p.m. और दूसरा दिन बोल रहे 11 a.m. आप डिसाइड करेगा टाइमिंग. चलो चलो. Water conveyance efficiency. Because if you know overall efficiency, remaining efficiencies are similar to it, Bhupender. Overall efficiency is only important for our exam. That is only basic formula. Using that only you can get everything. Understand that. That is only helpful for your exam. The ratio of quantity of water delivered, ratio of quantity of water delivered to the field. Kaha? At the field. Water delivered at the field to the quantity of water diverted into canal system from reservoir. From source, how many liters of water diverted to canal? So this is canal system. From reservoir, certain volume of water started journey. Certain volume of water started journey, Q into T. And finally at the field, certain amount of water delivered. After some losses, after evaporation loss and seepage loss, some amount of water delivered. That ratio is called conveyance efficiency. That ratio is called conveyance efficiency. Water delivered upon water from source into 100. Water delivered, yes, it accounts for transportation losses, correct. Water delivered by water from source into 100. So tomorrow at 2 p.m. you are busy. Riya garu, tomorrow 2 baje aap busy ho gaya kya? Water delivered by water from source into 100. That is the transportation losses. राजधानी लेट में चलेगा. राजधानी लेट हो गया. Water application efficiency, ratio of water stored in root zone, ratio of water stored in root zone to the quantity of water delivered to the plant. This is the delivered na? This is the delivered na? From that delivered, how much water is coming to root zone? From that delivered, how much water is coming to root zone? So, water at root zone, upon water at field. Water at field. You are applying water on the field. During application, for example, this is the field. Water is applied. During application, it is falling down. It is falling down, spreading on the ground level. Surface runoff water is moving away, spreading. And after absorption by soil, deep percolation, some amount of water drained into groundwater table, gravitational flow. After gravitational flow drained off, after surface runoff drained off, Remaining water reaches to root zone. Water at the root zone by water at field is application efficiency. Yes, correct, Viral garu. Clay soil is impermeable. Its absorption capacity is more, transmission capacity is less, losses will be more. Now, water use efficiency. Water use efficiency. Ratio of quantity of water used beneficially. Ratio of quantity of water used beneficially, including water required leaching to the quantity of water delivered. To the quantity of water delivered. Water used by plant. Water used by plant upon water delivered at field. Water delivered at field. So, total volume of water available at root zone, will it be absorbed by plant? 100% water absorbed by plant? No, no. In the total water available at root zone, some amount can be used to make it FC field capacity. Some amount should be utilized to make it hygroscopic water to be available. Remaining amount of water is used by the plant. Please understand. Yes, seepage losses considered in the previous case. So that is water use efficiency. Water used by plant upon water at the field. Water use efficiency. Now, storage efficiency. Water stored in a root zone during irrigation. Water needed to bring water content of the soil to field capacity. Water content of the soil to field capacity. This is a bit complicated. I will explain it to you. So you have the water content already existing. Water content existing 5%. Field capacity is possible 25%. So you are doing irrigation to make existing moisture content to field capacity. Existing moisture content to increase to field capacity. So that 20% of requirement. Existing moisture content to field capacity 20% is needed. So soil reach to field capacity. Soil reach to field capacity after irrigation. After irrigation. But in that, only 10%, for example 12%, stored at root zone. Remaining 8% is in the soil to make field capacity, but not available at the root zone. Within the soil, but not available at the root zone, only 12%. So what you can say, 12 by 20 into 100. 20 is to make existing to field capacity. 12 is stored at the root zone. 12 by 20 into 100. Yes, Harun, we want to increase any time during irrigation. The target of irrigation is to make any time to convert existing moisture content to field capacity. From that, plant is going to take. From that field capacity, plant is going to take. The target of irrigation, please understand, irrigation target is always this one, to raise existing moisture content to field capacity. That is only target of irrigation. Is that clear, guys? Now, what is water use efficiency? What is water use efficiency? So, plant can effectively take from stored water from root only. Plant is going to take effectively from the stored water in the root. That is 12%. But available water at the field capacity 20%. 12 by 20 into 100. Viral garu cheppandi. Next, consumptive use efficiency. Consumptive use is the total amount of water utilized for the plant for its growth, evaporation from surrounding wet soil surface, transpiration from plant. That is consumptive use. You know, we discussed consumptive use in hydrology. Consumptive use include three. That include three. You remember it. One, evaporation from surrounding soil. Evaporation from surrounding wet soil in the plants. Surrounding wet soil in the plant. Transpiration from plant. Evaporation from soil, transpiration from plant. Plus water used in metabolism inside the plant body. Water inside the plant body. Water used in metabolic growth, metabolism. So that three included consumptive use, that three. 8% remaining. Are you are talking about only root zone, Deepak Garu. That 8%, you are not at all talking about entire soil depth. Entire soil depth is involved in field capacity. But you are talking about only root zone. Root zone 12%, remaining soil 8%. So what is consumptive use here? Consumptive use here, please tell me what is consumptive use? Evaporation from soil, transpiration from plant, water inside plant body for the metabolism, consumptive use. To the net water taken from root zone. Root zone, water is available at root zone, water came to root zone. So net water available in the root zone, that ratio. Cu upon water at root zone. Cu upon water at root zone. Arey, how can you say negligible, Viral Garu? It may be negligible, it may be considerable, depending upon plant to plant. But still, we are unable to measure it, we say negligible, because our experiment lysimeter. Lysimeter is going to measure evapotranspiration, but water in metabolism accurately unable to measure, so we call it as negligible. Now, distribution efficiency. Distribution efficiency measures effectiveness, the extent up to which water has penetrated uniform depth throughout the field. The extent up to which water has penetrated uniform depth throughout the field. I will make it very simple and easy for this. This is agricultural land. Water is loaded here. And water released from this location. Will water uniformly distributed throughout the depth? Please tell me. will the entire area of agricultural land receives uniform distribution of water? Near to the field channel receives more water. Away from the field channel receives less water. Near to the field channel receives more water. Away from the field channel receives less water. That uniformness in the spread of water, that is measured by water distribution efficiency. That is measured by water distribution efficiency. Please check this. Water distribution efficiency. This is the formula. One minus yd by ym into 100. 1 minus yd by ym into 100. Yd, mean depth of water stored during irrigation. Average depth of water stored during irrigation. Yd, average of absolute values of deviation from the mean. Nothing but a standard deviation from the mean values. Standard deviation of the mean, that is taken as yd. 1 minus yd by ym into 100. Chalo, completed. So here we'll discuss small things. CIR. Consumptive irrigation requirement. This one Saket Saha. This one Tayanna completed. Tayanna. Consumptive irrigation requirement. Consumptive use minus effective rainfall. Consumptive use minus effective rainfall. Consumptive irrigation requirement. Consumptive use minus effective rainfall. CIR. Consumptive irrigation requirement. This course will end today. Any problem to you? Array, most important, we have finished already. Field capacity permanent wilting point completed. Duty delta base period completed. By today, irrigation efficiency completed. Remaining topics like Jujubi for GATE students. Just it's like cakewalk for GATE students. Consumptive irrigation requirement is equal to consumptive use minus effective rainfall. NIR. NIR. Net irrigation requirement. Net irrigation requirement. Consumptive irrigation requirement plus leaching. plus leaching requirement. Consumptive irrigation requirement plus leaching requirement. To make soil to be prepared for plant growth. To wash away any salts in the soil, agricultural land, water required, that is called leaching requirement. A CIR plus leaching is NIR. CIR plus leaching is NIR. FIR, leaching means water added to remove salt content from the soil, not by plant. Before land is prepared for agricultural activity, you are pushing some water into the soil so that excessive salt content in the soil is removed. That removal of salt from soil is called leaching. Removal of salt from soil is called as leaching. So FIR, field irrigation requirement. FIR, field irrigation requirement is equal to NIR, net irrigation requirement, upon application efficiency. Field irrigation requirement is equal to net irrigation requirement upon application efficiency. Finally, GIR, gross irrigation requirement. Gross irrigation requirement. GIR, field irrigation requirement upon conveyance efficiency. FIR upon conveyance efficiency. Gross irrigation requirement. Field irrigation requirement upon conveyance efficiency. GIR, gross irrigation requirement. Chalo, CIR plus leaching, because consumptive use minus effective rainfall you have taken CIR. So finally what is remaining to be considered? That should be net irrigation. Yes, Viral Garu, value grow on increasing. CIR less than NIR, less than FIR, less than GIR. GIR is highest value. GIR is highest value. So irrigation projects based on area. Command area. Area commanded. Irrigation projects based on area commanded. You know everything na. Viral Garu. Irrigation projects on area commanded. So first one we call a irrigation project as a major irrigation project. Major irrigation project. If the irrigation project can provide water needs of serve or provide water needs of more than 10,000 hectares. More than 10,000 hectares of land. That is major irrigation project. Major irrigation project. So 10,000 hectares is equal to 100 square kilometer area. 100 square kilometer area. Major irrigation project. Medium irrigation project, 2000 to 10,000 hectare, 20 to 100 square kilometer area. 2000 to 10,000 hectare, 20 to 100 square kilometer area. Minor irrigation project, up to 2000 hectare, 20 kilometer square area. Major, medium and minor irrigation projects. Major, medium and minor irrigation projects. Is that clear to all of you now? Major irrigation project, minor and medium. Chalo. We'll solve some questions. We'll go ahead with some questions. But tomorrow you'll have more questions. Today very few and easy theory question. Easy questions today. Tomorrow tough question. Tomorrow tough question मिलेगा आपको. The outlet discharge factor is Dinda garu cheppandi. What is outlet discharge factor? We solved in numericals also. Do you remember? Outlet factor is given. Outlet factor is given. Do you remember? In numericals also we have provided it. Duty based on the discharge passing through the outlet. Duty based on the discharge passing through the outlet. Outlet discharge factor, duty. समझ आ रहा है? Do you remember? We studied previously also. Outlet factor is a duty. Numerical questions also we considered it. अरे क्या हो रहा है? चलो हाँ वायरल गारू क्वेश्चन का बारे में सोच रहे ना आप. देखो सॉल्व करो, आंसर बताओ. Duty for the crop, duty for a crop at field is 800 hectare per cubic. Duty for the crop at field is 800 hectare per cubic. Conveyance loss is 20%. Duty at a head will be Yes. So you understand this? Duty is opposite to discharge. Duty is opposite to discharge. Duty inversely proportional to discharge. Na? Duty is equal to area by discharge. Duty inversely proportional to discharge. So what you are considering? Duty at head, design duty, is equal to duty at the field into efficiency. Design duty is duty at the field into efficiency. Viral Garu. Yes, for that only we have given this question. Please understand. Design value, actual value, you can go for this. For capacity, for depth, for discharge. But not for duty. But not for duty. Because duty is inversely proportional to discharge. Duty at head is less than duty at field. Understand? Understand this. Duty at head is less than duty at field. Duty is inversely proportional to discharge. Yes. Duty design value is less than duty actual value. It is per 1 cubic you are estimating now. That is why. Understand this? Chalo. Clear to everyone? Clear to everyone, guys? Anyone having doubt? किसी को डाउट होगा पूछ लो जल्दी. For supplying water to a rabi crop, kharif crop, sugarcane, the channel is designed for a capacity equal to or greater of the water requirement of. Please tell me. What is the answer? Channel is designed for a capacity of. Channel is designed for the capacity of equal to or greater than rabi plus sugarcane kharif plus sugarcane. Rabi plus sugarcane, kharif plus sugarcane. This one only, na? Rabi and sugarcane, kharif and sugarcane. Yes, maximum of sum. Maximum of sum you can take. Maximum of it. Sudhakar Garu. Oh, Viral Garu. Viral Garu, maximum you can take. Ratio of quality of water stored in root zone of crop. Sorry, quantity of water. Ratio of quantity of water stored in root zone to the quantity of water actually delivered. Water at root zone upon water at field. Water at root zone upon water at field. Water at root zone upon water at field. Application efficiency. Application efficiency. Harun, conveyance is water at a source. You will come na. Water at field by water at source is conveyance. Water at root zone by water at field is application efficiency. Harun. The outlet discharge factor is the duty at the head of. Outlet discharge factor is a duty at the head of what? Head of water course. Water course. Source na. Head of source. Source is nothing but water course. Source. Source is nothing but water course. सोर्स का हेड में लेना पड़ेगा बाबू सिकंदर एंड तायन्ना वाटर कोर्स इज नथिंग बट सोर्स यू हैव टू टेक सोर्स हेड ड्यूटी इज एस्टिमेटेड एट द हेड ऑफ सोर्स चलो डन so we'll continue tomorrow all questions are there these questions we will do it tomorrow